Now I talk about idiophones and the membranophones. Membranophone. I start with the idiophone. There's a definition of this. Any class of musical instruments, such as bell or gong, whose sound is generated by striking or rubbing, clogging, and so on. The material of the instrument under any special tension. It has some tension. Yeah. Okay. Yes, and we have some. We have we have some rectangular bar here. And we have modes, and this is a way. It's a way of the bar. It shows how it vibrates. Yeah, and we have some frequency. Here's mode first mode, and then the second mode. No, the frequency is F1, but then the second mode is same as this. Oh, it was 3, sorry. It should be here, and then yes, but then the frequencies are not multiplets as F1 is third here. It should be 5.0 times F1, and so it's a little bit complicated for those. So there are no harmonics, overtone. Yes, and we can see here the frequencies Fn. Frequencies. There's a formula here is P times the sound speed in the bar times the thickness of the bar, and some like this, and times Mn squared. The modes where Mn is, I think it's 3.0112, and then 5, 7, and 2n plus 1. Yes. So Fn is is directly proportional with thickness, and it's inversely proportional to the length squared. Yeah. Striking in the middle will, you can say, will reduce the second mode. Yes. Yes. Yep. Yeah. What can we say else? So we can have some problem. Yeah. Of course, we can have some. If we have a F1 is 22 hertz, 27 hertz, and the speed is 3,300 meter per second. Of course, we can find the length times 3,300 times the thickness, for instance 1 centimeter, divided by 812 times the length squared, times, let's see that as the first mode here. This is square, and this should be 75.5, and we can calculate L. It should be, you can do by a computer, or you can also just do it by hand, and L should be 1.1 meter. Yes, and yes, and you can say, how can we reduce the inharmonicity? Inharmonicity, we have and strengthens the pitch. We can add a resonator to the F1, and we can do something about the bass. we can hit at the middle of the bar to decrease F2. If we hit here, we decrease F2. Yes, okay. And yep. So there are some percussion instruments. Marimba with a resonator. No, with a resonator. There is a xylophone. It's made of wood, and so we have a vibraphone. We have a glockenspiel. Is a metal, and I think there's also a resonator for the vibraphone. Yes, and they are playing different situations. Yeah. Did I do this finished? Yes. There are no harmonic overtunes, and to make it a little bit strange, we can if we hit in the strike in the middle, we can decrease the F2. Yes, I've talked about this. Yes, and we can decrease the thickness in the middle of the key to do some changes about the inharmonicity or strings. I don't know how. Yes. Then we have yes, we have here other examples are of non-idiophones. You can also have a slagwerk. But we have to, and then have a P times VL times instead of thickness K, which is about M N second, and the modes have some other numbers, and K is, I think, is the square root of inner plus outer radius. Yeah. Okay. Then I go to the membranophone. And this is a class of musical instruments in which a stretch membrane vibrate. To make sound. And there's some technical stuff here, acoustics of a membrane. The modes have some two numbers, namely the numbers of nodes of the diametric nodes and circular nodes. This should be minus, plus, and this node diametric, one circular, and then we have one here, plus, minus is 1 here, one diametric, and then we have two diametric and one circular, plus, minus, plus, I think. Yeah. It's a 2.1, etc. Yes. Yeah, and the those plus and minuses are they are the plus and minus shows the relatively phasing. Come on. Relative phasing of the vibration of different parts of the structure in the modes. Yeah, a little bit complicated. We have here the frequencies. It should be like this. I can just 2p times A times the square root of the tension in Newton divided by the density. We all get it in Hertz. Yes, because I think this subject a little bit, I have no experiences with vibraphones and so on. T is tension and A is radius and density. And those XMN's solution to the Bessel functions. Or Bessel functions. Yeah. We have here M order is M order and an N number of non-trivial. Yeah, we have some Bessel functions like this, and it's wave number like this, and we put it set M we set M lige med 0 and solute it x.0 it's okay, like this. It should be wave number like this, and we put it to 0. We solute those Bessel functions and complicated stuff, and then we get it should be 2.5, 5.2, and so on, different numbers. Yes. Yes. Yeah, I can just tell about no harmonic overtones, change tune by changing tension and hit 2/3 of radius to minimize circular mode. Okay. So yes, okay. The so-called examples are so-called struck membranophones in timpani, played in Berlin, sarabande, and djembe, also tabla, struck membranophones, and then some plucked. It could be a katara. It's a pluck membrano. Okay, thank you.